Hello everyone and welcome to Techno Home channel. In the previous video we talked about necessary applications which almost every user should install on their PC, and I thought maybe it's better to make a separated video for MSI Afterburner, which I mentioned in that video. Before getting started, we will be so thankful if you hit the like button and subscribe to our channel. And now let's dig into it. Firstly, I see the necessity of explaining few basic information, which are overclocking and undervolting. Overclocking means gradually increasing the clock speed of your GPU to boost its performance. Clock speed measures the amount of processing cycles per second which your video card can handle, and it is set by the manufacturer, but you still may be able to change that a little bit. On one hand, increasing the clock speed results in more computing power and smoothing gaming experience, but on the other hand, it results in higher GPU temperature. In order to test that, we usually run benchmark tests to see the stability of the graphics card and also monitor its temperature to see if everything is alright. Undervolting is the opposite of overclocking. When you undervolt your GPU, it means that you are reducing the amount of voltage which your GPU is receiving from the power supply. We can basically undervolt till the moment we have the same clock speed but running on lower voltage. On one hand, it reduces the power consumption. Your PC or laptop will run on lower temperatures and they will be a bit quieter since their fans won't kick in much. But on the other hand, it's so hard to achieve and needs a lot of testing till you meet the sweet spot. Before getting into how you can overclock or undervolt your GPU, you need a benchmark tool to test changes that you apply to the graphics card. I recommend using 3D Mark application, which is available on Steam, but you can only use the demo version for free, which I guess is enough. When you open MSI Afterburner, you'll see a screen like this, which might be a bit confusing, but it's alright. You see a bunch of info in the main dashboard like GPU frequency, memory frequency, voltage, and temperature. There is one simple rule: avoid temperatures over 90 degrees. Okay. Core voltage, the voltage level that goes into your graphics card, which might not be displayed on the newer cards like mine. Power limit. The power slider lets your card draw more power from your power supply unit. As an example, if your card uses 200 watts, increasing it to 120% will let the card use around 240 watts. You need to do this if you're planning to overclock your graphics card. Then we have core clocks. It's clock speed of the GPU, which we talked about just earlier, and the memory clock. The memory clock is like your core clock, but it measures your GPU memory. Overclocking, first step is checking your performance, temperature, clock speeds, and FPS before changing any settings. Then write down all those information somewhere. Now you need to raise the clock speed. Start with something over 5%. As an example, if your max graphic card's frequency is running at something like 2000 megahertz, you need to raise it by over 100 megahertz for the core clock. Then you need to test for unusual graphical artifacts like glitches or even crashes. 5% should be stable, but you still won't see much improvements. And for memory clock is as important as clock speed when it comes to games with tons of textures. Try increasing it by 50 or 100 megahertz. Anything below 10% should still provide stable performance. As an example, I go with 50 megahertz. Now, the point is, if your computer crashes or games start malfunctioning, your hardware may not be designed for overclocking at all. You may also want to try increase your computer's temperature limit right here. After trying the previous steps, continue by tuning the GPU and increasing the clock speed and memory clock by 10 megahertz. So, as an example, I have tested this core clock and memory clock, and it didn't give me any crashes or glitches. I increase it like to 110 megahertz for the core clock, and then 60 megahertz for the memory clock, and I tested again. We have to test using benchmark tools or stress test, running games for a few minutes, and then we have to monitor our graphics card. And don't forget to tap on the apply option every time you make changes. Do the above steps until the Windows freezes or reboots. It means that you have reached your overclock limit. Then you can just decrease the clock speed and memory clock by 10 or 20 megahertz and run the test again and make sure everything is alright. As an example, I have reached my overclock limit at something around 150 megahertz for the core clock and 100 megahertz for the memory clock. When the crash happens at these core clock and memory clocks, I'll decrease these two options by 10 megahertz. As an example, I go with 140 megahertz with the core clock and 90 megahertz for the memory clock, and test it again, make sure everything is alright. When you've reached that overclock limit, you might stay on that clock speed and memory clock or turn up the power limit and temperature as well. Now you need to do the tuning again, slowly increase the clock speed and memory clock by 10 megahertz until you meet the overclock limit again. Also, don't forget to tap the apply button every time you make changes. The question now is, does GPU overclocking really help? Well, the answer is yes. While the benefit of overclocking on high-end graphics card won't seem much or necessary, it really has a good impact on lower-end cards, especially if your games are normally running on something like 40 or 50 FPS. By doing the overclocking, you might be able to boost the game's performance by 10 to 20%, which is noticeable and worth it for these cards. The other question is it safe to overclock your GPU? And the answer is again yes. It's okay if overclocking increases the temperature and stress on the GPU, but if it goes too far, which cannot be handled, that's where the fail-safe mechanism of the card kicks in and prevents the hardware from any damage by a system freeze or crash. For undervolting, first you need to make sure that you are running default manufacturer settings for voltage. Then open the curve editor and you see a table like this, which might be a bit confusing, but no problem at all. I'm here to explain it all. As an example, my max frequency is running at something like 2017 megahertz with the usage of 1100 millivolts of voltage. Okay, I'm going to keep the exact same frequency while using a lower voltage just like this. So now I have reached a spot where I'm using 2017 megahertz frequency, but using 1075 millivolts. Now I have to run a benchmark test or a game and see if any crashes or glitches will happen. Tuning this might take a lot of your time, but trust me, if you do, you will love it. I have reached a spot with one of my configs where it's maintaining almost the same performance while lowering my temperatures in games for like 10 degrees, which is insane. Of course, the benefits might differ from a hardware to another, but who doesn't like lower temperatures? And just as overclocking, undervolting is 100% safe. Thank you for watching this video. If you have any questions, let me know in the comment section down below. And don't forget to like this video, subscribe to our channel, and ring that bell so you won't miss our future videos. See you in the next videos and peace out.